Hey there guys, Erica here from Highway 49 RC. If you want to support the making of videos just like this one, consider becoming a channel member for a small monthly donation. You guys get early access to videos, and it would be a great way to support the content that I make. With that, welcome back to the Rocket Wrestler build, episode 5, where we are recreating the Mythbusters JATO rocket car. As you can see just behind me here, last episode we got the body completely put together. It is looking absolutely sweet. It's a 64 Chevy Impala body from Red Cat. And I've also got the rocket stack situated up on top. And today, you know what we get to do? We get to play with explosives. Oh yeah, we get to shoot off some rockets today, guys. Finally, 5 episodes in, we finally get to play with some rockets. So the type of rockets that I'm going to be using are these itty bitty little half-A rockets. So the plan is there are going to be 2 rockets stacked up in each tube, just like this. The rear rocket, after it finishes firing, is going to ignite the front rocket and continue the burn. In theory, that's the hope. But I want to go shoot one of these off just to see what it does, and then we're going to try sticking 2 in the tube to see if it actually does burn from one to the other. I'm a little skeptical of that, but let's go find out. Alrighty, so I've got my rocket stack clamped down to the welding table. I've got a 2S battery for ignition. Thank you, birds. And I've got some alligator clips to clip onto the igniter. So the way we're going to load this up is I'm going to put a little piece of metal down the tube so that the rocket doesn't slide in too far, because I want to see from the edge of the rocket outward. I think you take the igniter, you stick it in there, pull these apart a little bit. Got to make sure it's touching the propellant, so I got to kind of hold that in there. Stick this plug in the hole, and theoretically, we are good to go. I'm going to get my leads clipped up to the igniter here. Got my safety glasses on, my super safety flip-flops, and we should be good for launch. Firing in 3, 2, 1. Woo! Oh, that was sick! That was a lot louder than I was expecting, but holy cow. Major success, guys. That was incredible. Alright, so that was freaking cool. I think we all gotta admit. So now what we're gonna try and do is stick 2 rockets down the tube and hope that the rear one will ignite the front one after it's done burning. Let's give that a try. Alright, let's load her up. Make sure we got the rockets facing the right way. There's 1. There's 2. Got my igniter, my plug. We should be good to go. Let's give it a shot. Alright guys, here we go. Firing in 3, 2, 1. Yes! It worked! Oh, that was so cool! That was incredible! Okay, so now what we need to do is we need to build an ignition system to light off each of these 3 tubes sequentially with a delay between each one, because obviously the delay is for while it's firing. So the top one's going to go off, and then we're going to have about a 2-second delay while this one is firing before the middle one goes off. Again, 2-second delay while it's firing. And then the 3rd row is going to go off. That's the theory. Let's go inside. I'll draw up a picture for you guys and explain how it's all going to work in a little bit more detail for those that are more tech savvy. Alright class, calm down, listen up now. So, this is how our ignition system is going to work. We've basically kind of got 2 main circuits. We've got our power circuit highlighted in pink for our igniters, and our control circuit highlighted in green here. So our flow of control is, we've got power from the battery up here that comes down into this power relay, as I'm calling it, that is controlled by the receiver. And there's 2 of them that cascade into each other. Now, these are just little RC light switches, essentially. The reason I'm not building my own switches out of servos is because I need utmost reliability for safety purposes. So I need something that's actually going to function properly and not be all baloney nonsense, the way the switch on my Splash is. but I've got them cascading into each other so that power comes in, hit the switch on the radio, power comes out, goes into the next one, hit the switch on the radio, power comes out here. So that means I have to flip 2 switches on my radio in order for the rockets to ignite as a safety feature, which I think is a great idea. I don't know about you guys, but I think that's great. So out of our second power relay, or light switch, essentially, we've got power going straight to one igniter without any delay. That's going to be our top rocket tube. But we're also pulling power off of that same line that comes over here to this relay that, when told, will close and set igniter 2, and also with igniter 3. Now, these guys are being told to close by this green circuit here. Each of these combos of a resistor and a capacitor act as a delay circuit, essentially. I'm going to have to do some experimenting, but from what I understand, this little circuit here with the resistor and capacitor should delay the flow of power to the coil. So what that means is after igniter 1 fires, there's going to be a delay before relay 1 closes and sets off igniter 2. And then there's going to be another delay right here before relay 2 closes and sets off igniter 3. Does that make sense? I really, really hope that makes sense. The highlighting has definitely helped me understand it a little bit better. My first protocol is going to be getting my power relays, or my light switches, hooked up to my receiver, getting the switches on my transmitter all hooked up and programmed and calibrated and nonsense. Okay, folks, so I've got my switches all figured out. There's little blue lights on them, on these guys right there. So bam, there's one, and there's my second one. And the second one does not turn on if I flip the main ignition switch. So this is my safety, turns on that one, and this is my ignition switch, turns on that one, and as you can see, we got 6 volts coming out. Aw, yeah. So I've been working away here, guys. I built a circuit on this perf board using some capacitor and resistor values I found online, or based off of some values that I found online for the delay. That did not work. So I have been, for the last hour and a half, playing with resistor and capacitor values to get this thing to have a long enough delay. Now, the issue that I'm kind of running into is that the relays trip at 6.5 volts. That's the lowest voltage that they will activate at. I'm running 7.4. The batteries can drop down to 6.4, 6.5. So right on the cusp of where those relays are going to activate. Now, the way that the resistor and capacitor circuit works is the resistor restricts the current that flows into the capacitor, so it slows down the charging of the capacitor. But there's a voltage drop across this resistor, which means basically on one side I've got 7 volts and the other side I've got 6.5 volts. I did time the burn and it came out to 4 seconds, so I've been playing with the resistor and capacitor values to try and get up to 4 seconds with a low enough voltage drop across the resistor in order for the relays to still trip. And it came down to me using some 8200 microfarad caps. These things are huge. And I even added another 2200 on here and it's still not enough. So what I'm going to do is order up some 10,000 microfarad caps, and I'll probably end up using 2 of those per relay on this thing. While I've been waiting for the new capacitors to show up, I decided to make a little board here on the side of our rocket stack for our igniters to plug into. So the 2 wires for the igniters will just go into each of these terminal blocks, making everything nice and clean. We've got black for the ground of all of them, and then white for the top, yellow for the middle, and red for the bottom. I think it looks super clean. This is going to make things really easy to reset after our runs. And this is also on the opposite side of the camera, so you're really not going to see it at all. You're just going to see the nice clean side. So my 10,000 mic capacitors have shown up, and I have gone ahead and completely built our ignition circuit here on breadboard. So this is the first stage right here, and this is the second stage. I've made a slight modification to the circuit design. I've made it so that the second stage does not receive power until this relay is closed. So once this relay closes, this part of the circuit gets power and starts its delay timer. So I'm going to put my microphone up real close to the relay so you can hear them click, and I'm going to go ahead and turn it on and show you guys the delay. In 3, 2, 1. And just like that, our circuit is working. So now what I'm going to do is build this circuit on a piece of perf board that I have currently lost. I don't know where it went, but I'm going to put this on perf board, make it all nice and clean looking, and I will get back to you guys once that's done. Okay folks, here is the circuit board that I have built. Turned out pretty good. Took a lot of head scratching just because I tried to do everything perfectly the first time, so I spent a lot of time brainstorming, trying to figure out where everything needed to be, but eventually I got it. I made some tweaks to my resistors, and it's looking pretty good. So it is time for a proper test of this thing now. Let's go ahead and hook it up to my switch array, and I'll go ahead and put my microphone down close to the relays so you can hear them. Turn that one on to prime it, and there went one. So we've got some sort of problem here. I think I heard one of the relays go off, but not the other one. So I'm gonna have to maybe check my battery voltage and figure out what's going on here. Oh wait, it's because my BEC is set at 6 volts, not 7.4. Okay, that's an easy fix. Hang on a sec. Okay, got my BEC set to 7.4 volts. Let's give this another try here. Prime it, and there we go. There's 2 clicks. So with that working, now all I need to do is hook up the igniter board somehow, and then we can go give this thing a test. It'll be sweet. All right, everything is wired up. I think it's time we go outside and give this thing a proper test. This is gonna be the first time firing off 6 rockets. I checked all my outputs. They're properly in sequence. I've got it all hooked up right. The relays are working. Let's go do this. There we go. All of our igniters are in, and we are ready to launch, guys. Okay, guys, here's the big test. Turn our power switch on. Rockets are primed, ready to launch. Firing in 3, 2, 1. Aw, dude, that was epic! Not quite a full success, but very close to it. Our second set of rockets went off perfectly. The switches sometimes have a bit of an issue with getting powered properly, which is annoying, but otherwise, that was freaking sweet. So we're gonna have to do another test to make sure that all 6 go off, but I mean, that was incredible. Absolutely incredible. Okay guys, we are set up for another launch. I've only got 5 rockets in there right now because I couldn't get a 6th one in. The tubes are really tight because of the variation in the size of the cardboard tubes. So I'm gonna have to maybe drill out the rocket stack a little bit more. But it's time to give it another test. So we are armed, firing in 3, 2, 1. Same problem. See if we can re-trigger the last 2 sets. 2, 3, 4. Alright, we still got a problem. Okie dokie. So while these little switches are great, they're giving me problems. So what's happening is I trigger the first one with my switch as the safety, and that one works fine. And then I trip the second one to launch the rockets, and the first bank of rockets goes off just fine. And then when it goes to fire the second bank, the little blue light on this thing starts flashing for some reason, and thus cuts power coming out of it. I think that it's probably because we're literally just shorting the wiring together, and it doesn't like that, so it is smart enough to detect that we're just shorting the wires, and thus it cuts off the power so you don't short your battery and all that, yada yada yada. And the other thing that I did do is I drilled out the rocket stack tubes by a 32nd of an inch so that the rockets will actually slide in and out nicely, because I was having issues actually getting the rockets in the tubes. I was having to kind of like really shove them in there, and I didn't like that, so I went ahead, drilled it out, and it should be good to go now. So I've been tinkering around with my ignition system a little bit. I tried out a servo switch, that didn't really work, had some issues with that. I talked to my dad, and he actually had a good idea. He suggested opening up my endpoints. Reason being is that the threshold for the switches to go on and off may be too close to the pulse width that the radio is actually putting out. Therefore, if there's fluctuation in it, the switch isn't going to like it. So I've got a couple igniters here since I've got no more rockets, but this should at least hopefully rule out whether or not it's the fact that we're shorting wires together or not. So let's go ahead and give it a try. Primed, and let's see. There's 1, 2. Nothing on the third one, and our switch is blinking. Okay, so I think it's something to do with the fact that we are shorting stuff together. Okay folks, I have yet another experiment to try courtesy of my dad. He suggested adding a third relay into the circuit. Now, essentially what this relay is doing is taking the current flow off of the switches. Because before, all the current to set off the igniters was going through the switches, causing a current spike, and I think setting off a failsafe sort of thing in the switches. So this relay should divert that current so that it's coming straight from the BEC through this relay to the board instead of through the switches. So let's give this a shot. Primed, 3, 2, 1. There's 1, 2, 3. Hey, that worked! Except one of my switches is blinking now. I feel like I need to do another test run to be sure before we go and fire this. Okay, I'm reset with 3 more igniters for test 2. We're armed, firing in 3, 2, 1. There's 1, 2, and 3. Awesome sauce, guys. That worked fantastically. So I'm going to take this relay, integrate it into that circuit board, and then we'll go outside and shoot off some more rockets. Alrighty, folks, I've got my third relay integrated into my ignition board here. I've got a fresh stack of rockets in there, all 6 of them. The larger diameter holes in the rocket tubes made a ton of difference for inserting them, made it super nice and easy. They're all wired up with the igniters in them, and it's time to shoot them off. Rockets are armed, firing in 3, 2, 1. Damn it! Alright folks, I've got something else to try here. So what I've done this time is I've completely bypassed the BEC for the igniters. So the power to the igniters is coming directly off the battery, which should hopefully mitigate any sort of voltage drop from a current spike. So for those that are really interested in the way I have this rig wired up, I've drew up a quick block diagram here of all my different components, and then I've drawn an updated ignition system circuit diagram. So essentially from the battery, go into the BEC, go into my safety relay, and then through to my ignition relay. So those two got to get turned on. For this relay to get turned on, which switches battery power into my first igniter, which goes off, and then goes into my first delay circuit, which times it out to about 3.5 seconds. Then it will set off relay 2, which will close power to igniter 2. And once relay 2 closes, that will start the timer circuit for relay 3. So once this timer is done, it will trip relay 3 and thus lighting off igniter 3. Hopefully that all makes sense. Also, I don't really know why the BEC is still in the circuit at this point. I'm considering just straight up taking it out, but for now it's working, so we're gonna leave it as is. Let's go ahead and give this a try. We're gonna try it 3 times before we go and put rockets on it. Armed, firing, 3, 2, 1. All right, that one worked. Let me reset and we'll do it again. Okay, test 2. Armed, firing in 3, 2, 1. Awesome sauce. Test 3. We're armed, firing in 3, 2, 1. Gorgeous. Okay, that's 3 successes, guys. Let's go back outside for the I don't know how manyth time and put some rockets in our rocket stack and give this a go. All right, we are wired up and ready to go. Firing in 3, 2, 1. We did it, guys. We finally got all 6 rockets to fire off properly. The delays were a tad bit long, but honestly, I think for what we've got, it's plenty good enough. What do you say we do it one more time, just to be sure? I think that's a great plan. Rockets are armed, firing in 3, 2, 1. Well, that's not quite what I had in mind. So that one, guys, was a little strange. I'm not sure why they went off the way they did. I feel like I gotta try it again now to see what the issue is, but I don't want to keep burning through rockets. We've already burned through like $50 worth of rockets in this video. All right, screw it. We're gonna do this one more time. Armed, firing in 3, 2, 1. Hell yeah. So as far as I can tell, our ignition troubles are now behind us, which is great. We've got 83% launch accuracy according to my calculations, which, you know what, I'll take. I think our one misfire that we had, the second one, I'm pretty sure had to do with a bad igniter or some other weird thing. I don't think it was my circuit. I think it was something with the igniter. So I'm okay with that. I need to go buy up all the rockets I can get my hands on because we've gone through about $80 worth of rockets today. Yeah, hurts the pocketbook just a little bit, but hey, it's all in the name of science, right? Oh yeah, all in the name of science. So I need to clean up all this wiring, get it routed into the body, get a nice connector going between the rocket stack and the ignition board. Basically just get this thing all cleaned up and ready to go for next episode. And a couple hours later, we are left with some not too messy wiring. This wire here is coming from my rocket stack. It's just coming underneath the Velcro strap to kind of keep it out of the way. That's going to the board in the back here. Runs past the shock tower, and the rest of the wiring for it is also attached to the chassis stiffener link. But overall, aside from this little clusterfuck of nonsense, it's not too bad. And with that, my friends, the Rocket Wrestler is finally done. Our Mythbusters JATO rocket card tribute build is finally complete. All the wiring's tidied up. This thing's ready to go. The ignition systems are working. All that's left to do is actually go drive and shoot some rockets off on this thing. Yeah, that's gonna be next episode. I'm gonna tease you guys for one more episode, and that's when we're gonna go do the actual runs, which is gonna be freaking sweet. I'm super excited for it. I hope you guys are as well. If you did enjoy this video, please do leave a big fat thumbs up. If this does happen to be the first video that you have seen by me, make sure you go down, hit that subscribe button, leave a comment down below what you thought. If you want to talk with other fellow RC enthusiasts, my Discord's a great place for that. If you want to keep up with behind the scenes, Instagram at highway49_RC is good. And if you want to support me and what I do, consider becoming a channel member or joining my Patreon. Thank you to my patrons and channel members that are currently supporting me. You guys make what I do possible. So that's it for me, guys. Thank you again so much for watching, and I will see y'all in the next one.